we are at CPQD and I will give you a brief tour around our Optical Communications Lab. Please follow me. Here, our team is able to perform high-capacity coherent and non-coherent transmissions. Our lab is equipped with high-bandwidth modulators, analog-to-digital and digital-to-analog converters, and optical spectrum analyzers, and a real-time scope, which works at 80 gigasamples per second when using the 4 channels or at 160 gigasamples per second using 2 channels. Here we have a setup for unrepeated transmissions. This is an area in which we have very important results. We have a 2000 km straight line link employing standard fibers. We also have a few hundred kilometers of special fibers with low loss and large effective area. We have tens of external cavity lasers and some tunable lasers for C-band and L-band. And I have one more place to show you. CPQD also hosts a community lab for the Telecom Infra project, supporting trials based on open and disaggregated networks. Thank you very much for joining us on this virtual tour. See you next time.
Hello everyone, this is the Optical Sensor Lab. Here we develop applications for various sectors like power plant, oil and gas, industry and others. We work with several optical techniques like optical interferometer, fiber grating, spectroscopy and distributed sensor, DAS, DTS, DTSS. Now, I would like to show you some projects in progress. In this project, we are developing a solution for monitor multi-parameters in the underground distribution network branch, where we monitor temperature, partial discharge, current, and intrusion. All the sensors are based in the fiber grating technology. In this project, we developed a hover to monitor the quality of the power cable. And finally, in this project, we are developing an underwater communication system solution. Thank you so much.
Hi, I'm going to show you some of the processes and equipments that we have here in our lab for integrated photonics in CPQD. Here we have some vacuum ovens used for curing and baking different kinds of polymers and materials. Here are some regular and convection ovens used also for baking and curing different kinds of materials. These are spinners and hot plates used for spin coating and also baking, especially resists and also different polymers. For metallization, we have a DC sputter for depositing thin films of different kinds of metals, especially chrome, gold, titanium, and aluminum. For optical lithography, we have a Carl Zeiss MA6 aligner in which we can make patterns down to 1 micron wide. This is special for different kinds of devices that we make here in our lab. We also have chemical hoods used especially for resist developing and also wet etching, especially of metals. For dry etching, we have an RRE with an ICP module integrated to it. This equipment we use for plasma etching of different kinds of films that we deposit in our processes. Finally, for measuring the chips that we make here and other chips from different foundries, we have this experimental setup for electrical and optical measurements.